In this video, we are going to be discussing two topics. We are going to be discussing how to draw angles and how to change angles from degrees to radians. So, first we need to talk about what an angle is. So an angle is made by rotating a ray. So again, if you remember, a ray is a starting point and then a line from that point that goes in a direction forever and ever and ever. So if we rotate that ray either clockwise or counterclockwise, we get an angle. So we call the starting side the initial side. So we have an initial side of something. So we can say that this is the initial side. And then we would have some place where it would end, and we call that the terminal side. So the terminal side is where you terminate. It is where you are ending. So for instance, if we rotated this ray, let's say it started here at B and then kept on going through A, and we rotated it counterclockwise and it ended up looking from B on to C, then this is what this angle of alpha is talking about. So we could also have the initial side and the terminal side on this case swap, and we're looking at the angle going in the other direction. So the direction of rotation is actually going to start to be important to us. So we actually have two types of angles. We have a positive angle, and that positive angle is where we have your initial side and your terminal side, and the angle is made when you make a counterclockwise rotation from your initial to your terminal, and the opposite, going from your initial to your terminal, going in a clockwise rotation, that is going to give you your negative angles. So this could, for instance, be, I don't know, like 72 degrees, and over here this would be something like a negative 45 degrees. So we're going to have positive angles and negative angles. So the polarity of these angles tells us which direction that it rotated to create this angle. And that's important because we need to know which way things rotate in order to how they started to where they ended up. So to make our lives easier, we typically put angles in what we call the standard position. And standard position is basically putting angles in the Cartesian plane. So the Cartesian plane is your coordinate system. It's your XY axis, where your your vertex, your endpoint, is going to be located here at the origin of 0, 0. So this is at 0, 0. Your initial side, so this is always going to be your initial side, is always going to be on the positive x-axis. So that's going to be very, very important. Our initial side will always start on that positive x-axis. So we started here at the point 0, 0, and then we go out on the positive x-axis. So that is our initial ray that we're looking at. So using that system, we can then go and quickly understand our angles and how they rotate. Are they positive? Are they negative? How far have they rotated? And it's all dealing with that positive x-axis as our initial. So these are two little example pictures. So again, we have our initial sides on both of them on the positive x-axis. Here we have a positive angle because it rotated counterclockwise, and here we have a negative angle because it rotated clockwise. So positive is counterclockwise, and if you think about it, you had to go up initially to start rotating this thing, and here you had to start going down to start rotating. So there's your positive and your negative by using that positive x-axis. So we also have a different type of angle. So we have what's called radians. So radians are used when you are dealing with circles, because it is a unit that is created by using the length of the radius and how it relates to the circumference of a circle. So again, you only use radians when we're talking about circles of things. So that's why everything in a triangle so far was degrees, because we weren't talking about circles in any way. But we're going to start using circles now, and those circles require radians. So just so you guys get an understanding of what that looks like, I'm going to show you a GIF. So we just laid the radius down on top of the circumference, so that angle that's formed is called a radian. And as you can see, as we keep adding these around, we eventually get to pi. So this is where pi is coming from. That's 3.14 radians, so that's half of the circumference. So that means that in an entire circle, there are 2 pi radians. So those are going to be important for us. So things that you need to know. There are, in a completed circle, so in a circle, there are 360 degrees. There's also 2 pi radians. So each of these form a full circle. So that's why you see that to go from, if we wanted to convert from degrees to radians, I need to multiply by pi over 180, or from radians to degrees, 180 over pi, because what this is just a conversion factor, and this is a dimensional analysis issue. So we're saying that 2 pi is equal to 360 degrees. So I'm able to get rid of my degree sign. So let's say that, we'll just say degrees here. So the unit of degrees would cancel, and I would be left out with my radians. And again, the reason why it's pi over 180, well, 2 and 360 are going to simplify to get you pi over 180. And pi and 180 are both half circles. So if you think about a half circle, that's 180 degrees, and it's also going to be pi radians. So these two things are equivalent, so that's why we use that to convert between the two. So in our first examples, we are going to practice converting between degrees and radians and degrees. And in the next part, we're going to be drawing angles. So let's look at some examples. So we're asked to go from degrees to radians. So I'm going to take this 60 degrees, and I'm going to multiply by the conversion factor. So since my degrees, so if you go back to your dimensional analysis, degrees is up in the numerator, so that means I would need to put degrees in my denominator. So that would be the 180, and there are pi radians in 180 degrees. So the unit of degrees cancels, and this is going to be 60 pi over 180, because I'm just multiplying straight across, and then I can simplify this. So this is always going to be kept in a fraction, and just simplify your fraction. So always, always, always keep radians, if you can, as a fraction, and keep the pi outside. So also keep pi, and that's actually going to make it easier, because that just tells me, hey, I just need to go and simplify 60 over 180. So I'm not going to touch that pi. So 60 over 180 is the same as 1/3. So this is 1 pi over 3, or just pi over 3. let's try the next one. So again, I'm trying to go from degrees to radians, so I'm going to keep my degrees in the denominator and my radian unit in the numerator, so the degrees cancel. So this is the same as saying negative 840 pi over 180. So I'm going to start simplifying. So I can already cross out those zeros. So 84 over 18, let's see, that's 42 over 9. And then both have 3's in common. So that ends up being 14 pi over 3. And one thing you may notice is that I didn't write the radian unit next to it. So a lot of times when you are talking about radians, the part with the pi, and you're talking about an angle, is good enough to basically describe that you are using radians. So that pi left there, when you're talking about an angle, is referring to radian unit. So it's almost like an invisible unit, but it is always there. So there is always still a radian unit off to the side. Just typically, if you're talking about an angle and you see pi, they are talking about radians. So it's just typically dropped. Now, that doesn't, so if there is no pi, then you still see the radian unit next to it. So for example, if I didn't write pi with this 2, then it's just 2 radians. So you just need to understand that if you see a pi, we're talking about an angle, we're talking about radians. So let's go the opposite direction now. So let's go from radians to degrees. So we have 2 pi over 9. So again, as you can see, the radian unit isn't written, but since I know that this is an angle, I know that this is radians. So that means I need to put my radian unit in the denominator, which is pi for my conversion factor, and 180 degrees in the numerator. So what's great about this is that you see that the pi's are going to cancel right away. Just like the units of degrees canceled, our pi's canceled. Now, that won't always be true if there's no pi to begin with. So if you had like 2 radians, then the pi's aren't going to cancel, but the unit of radian would, because there would still be a unit of radian right next to it. So it's just something to keep on the lookout for. But a lot of times the pi's themselves are just going to cancel. So we would then just do this math. We would just do 2 times 180 divided by 9, and we get out 40 degrees. So we can try the next one too. So again, we have the radians of 72 pi over 3. So I'm going to multiply by the 180 degrees over pi radians. The pi's are going to cancel, and I can just put this into my calculator, and I get out negative 4,320 degrees. Now, for some of you, that may start to feel a little bit weird. You're like, wait, why would we have such a large degree? So we're going to talk about that in a second after you guys try out these 2 U-try problems. So try these out and come back and see what you get. All right, so on the first one, you should have gotten a negative 19 pi over 36. And on the second one, you would have gotten 225 degrees. So let's talk about drawing angles and why you can have such large angles and why it makes sense. So let's look at this first example on how to draw an angle. So when you're drawing an angle, we need to remember that our positive x-axis is always our initial side. So this is the side I always want to start with. So the first thing I want to know is, do I need to start by going up, or do I need to start by going down? So this is my first question that I need to talk about. So if my angle is positive or if my angle is negative. So we have a positive angle here. So that means that I am going to be drawing this angle by starting to go up. So the nice thing about it on the Cartesian plane is that we have a bunch of 90-degree angles made here. So if you look at it from this horizontal to this one, to this vertical line, that's 90 degrees, so this is 90 degrees. Then we have another 90 degrees over here, and if we add those two 90s, we get 180 degrees. And then we have another one, so this would be 270 degrees. Then we have another 90 degrees, so this would come back to 360 degrees. So it started at 0, it went to 90, to 180, to 270, to 360. So that means that my angle of 210 is going to be somewhere between this 180 and this 270 and a little bit closer to the 180. So when you are drawing these angles, what you need to do is you're just making a rough sketch. The important piece is going to be this. Let me actually change the color so I can actually say it. So it's going to be this blue piece that's talking about this rotation. So this blue thing is 210 degrees that we rotated positively starting at the positive x-axis, and we ended up somewhere over here in the third quadrant. So this is a sketch and this is done. So the thing you need to make sure to do is you have this little blue line and you have the green arrow at the end, and it is as close as possible. So like if I had 265 degrees, my line would be a lot closer to the 270 than it was to what I drew over here. So let's try and look at this next one over here. So again, this one's a negative, so that means I'm going to start by going down. And this time, since I'm going down, this would be the first 90 degrees I see. This would be the second 90 degrees I see. The next 90 degrees I see. The next 90 degrees I see. But wait, our number's larger than this 360. Well, if you think about it, you can rotate more than a full circle. Like if you started spinning, you're going to go more than a full circle around. You can keep on going and going and going. So that means I can just keep on adding 90 degrees to this number. So after 360, this would give me a negative 450 degrees. Then I would have negative 540 degrees, then negative 630 degrees, then negative 720 degrees, so forth and so on. So I can keep adding 90 degrees every single time until I can find a window that I'm between. So that means that I need to go past the 90, past the 180, past the 270, past the 360, and look, I kind of made a spiral. So this spiral is telling me that I keep on rotating. So I know that I need to stop at 384, and that's going to be between this 360 and this 450, and going to be closer to 360 since it's only 24 away. So that means I'm going to just end it here. So we can see that we started by going down because it is a negative angle, and then I had to keep on rotating. So the thing is, you can rotate tons of times. So you can keep on going in this spiral pattern until you finally get to the angle that you're looking for. So The two things you need to draw when you are sketching these angles is the little spiral piece and then the end arrow. So always making sure that you start on that positive x-axis. So that's your starting point of you drawing your spiral. So when we're talking about radians, it's the same kind of thing. So I could do this over and over and over again where I say, okay, I'm starting at my positive x-axis. This is 90 degrees, and I can go and I can calculate what 90 degrees is in radians. And 90 degrees in radians is pi over 2. Then the next one would be pi. Then the next one would be 3 pi over 2. And the next one would be 2 pi, and so forth and so on. So it would keep on going around and around and around multiple times. So that's a lot of work, especially when you're dealing with fractions and knowing exactly like where 5/3 is relative to all these fractions. So a quicker way of doing this is actually converting this fraction into its decimal version of itself. So if I take 15 over 2 and I divide 15 over 2, so I'm keeping the pi out, so just 15 divided by 2, I get out 7.5 pi. So why did I do that? Well, because decimals is actually something that's a little bit easier for me to understand and think about. Because if you look at our x-axis, each of these is a single pi, and the in-betweens, our y-axis, are going to be half of a pi to get to the next place. So that means that this is actually 0.5 pi, and this one over here would be 1.5 pi. So now I'm looking at 7 pi and then half. So that means I need to go 7 full pi's and then go half of a pi. So this right here is how many times you need to hit the x-axis. And then this piece tells you like how much more you need to go. So since we're going 7 pi, that means, so 7.5 pi, I'm going to touch the x-axis 7 times. Since it was positive, I'm going to start by going up. So here I am on the x-axis. So here's me hitting the x-axis for the first time. So as you can see, this is 1 pi. Then the next time I hit the x-axis is 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So at this point I have now hit 7 pi. I've hit the x-axis 7 times. So I just need to go half more. So since the y-axis is the halfway point between the next pi, that's basically telling me any decimal that's less than 5 or 0.5, I just need to stop before I hit the y-axis. If it's more than 0.5, I just need to go further than the y-axis. If it is 0.5, that means I just need to land on that y-axis. So here is halfway to the next one. So in my opinion, out of the years I've been doing this, this is the quickest and the easiest way to sketch radians. So another thing you could do is you can convert that 15 pi over 2 into the degrees and then draw it that way, but that takes some work involved as well. So it's a lot easier to simply just divide that fraction, count how many times you hit the x-axis, and then the decimal tells you, do you need to go past the y-axis or not? So let's try it again. So let's try this -5 pi over 3. So again, I'm going to start by changing this into its decimal version. So 5 divided by 3 gives me a -1.67 pi. So again, the pi is still there. So since it's negative, that's telling me I need to go down. So I'm going to go to the 1 first. So that means I'm going to hit the x-axis here. So here is me hitting it for the first time, which is 1 pi. The 0.67, so I'm going to just draw this in a different color, tells me I need to go a little bit more than half. This is more than half. So that means I need to go more than half to the next x-axis, which means, hey, just go past that y-axis and you're done. So your units place is telling you how many x-axes you need to hit. The decimals are going to tell you do you need to go more or less than the y-axis. So here are 2 for you to try. So these are your 2 sketches and how they should look. So make sure that your spiral matches and the arrow is in the right quadrant.